Okay, we are live. Am I audible, guys? Yes, we are live. Okay. Good evening, everyone. This is Ashank David. Welcome to Coders Arcade and welcome to our 15th session of DSA Live for Placement Series. And this is Ashank David, and today I will be talking to you guys a little bit of DSA concept, where I will be continuing from where we left in our yesterday's class. In the yesterday's class, we have done stacks using linked list implementation, and in today's class we will be doing queues using linked list implementation. So we have already finished our linked list and we have already finished our basic stacks and queues with the help of arrays, and today I will be doing it with the help of linked list, and I will be creating up the queues. So if you are pumped up for this, please do like and share this live stream, and share this live stream as much as possible so that it will reach those people who really needs to learn about queues, data structure and DSA. Also, please do like, share and subscribe to our channel Coders Arcade so that you won't miss any future updates about whatever we are going to talk about in terms of technology. We keep on posting the content on our channel so that everyone is updated. So please do like, share and subscribe. Now, without wasting any more time, I would like to just start with our DSA live session, and let us go right into the topic. Let me just open up the whiteboard so that I can start explaining you what we are trying to do today. Okay. So today we are going to do the queues implementation, basically linked list implementation of queues. So we are going to create queues with the help of a linked list. For linked list, we have already covered all the concepts related to linked list. So if you haven't watched our previous live sessions, I would recommend you to go ahead and watch the live sessions as well. Also, here a reminder, we are doing object oriented programming. We are actually using OOPS concept in C++ to do and solve all these kind of problems in terms of DSA. So if you are not comfortable and you want to learn C++ object oriented programming, I have created a playlist where I have explained you all about it. It's a 5.5 hour playlist, so you can go ahead and watch that as well. Right? Next, we are gonna start our class for today, where I am going to tell you about this queues. We are going to implement the queues using linked list. So let's do that. All right, guys. Okay. So here we go. We have our whiteboard. I hope so that I am audible and also I am very much clear to all of you. If you feel that any issue with the mic or camera, please do let me know so that I'll be able to fix that problem. Okay, let us start now. Okay, so here, what exactly are queues? Today we are actually doing queues. Okay, we are going to do queues, but queues we will do using linked list. Okay, queues using linked list we will do. Now, we have understood about already what exactly is the linked list, where linked list is the data structure which allows us to store the data in a linear fashion, and we could do all the operations onto it We can do everything related to what we could do with arrays, but in a very efficient manner. We have already done this. We have already done queues. Then queues are another data structure which allows us to store the data in such a format that the elements which are placed into the queue are the first element which comes inside the queues are treated first, and then they are left before only. For example, in this case, sorry for the interruption, in between this can happen, so I need to manually set it up. I am the only one going live today, so bear with this camera issue. In between I need to keep on pressing one button, and in between it can go off. So sorry for the interruption, but we'll continue. Okay, so in this case we already know about linked list, we already know about queues. Queues data structure implements the concept of, this is going to be implementing the concept of first in, first out. First in, first out, or in this case, in the short form, we call it as FIFO. FIFO, first in, first out. Okay. Now, we have done it in the terms of arrays. I have shown you already the array implementation. It is done. In today's class, we are going to talk about the linked list implementation today. Okay. So what I have told you about, what have I told you about the array implementation of the queue? Basically, what I have told is that, imagine this is the array. Before I start with this concept, it is very important and necessary for us to learn about and revise about how the concept and logic of queues with the help of arrays works, because until and unless we don't understand that, it becomes very difficult for us to implement that into linked list. So we need to understand what are the components that are going to be used in terms of linked list for implementing the queues. Understood? We need some variables like front and back. That is why I am going to explain you that array implementation really quickly. We have already done that, but we are just revising it. So in this case, when we had an array, to implement the concept of first in, first out, we had two variables called as front and back. If you remember, I have told this before, which are by default set to -1 as the index, which are already set to -1 as the index. And if I want to implement or add anything, the concept of first in, first out is very important here to maintain. And how it is achieved? It is achieved because we can use first front and back variables to implement the concept of first in, first out. Okay. Good evening, sir. Yashas Gowda, DL. Good evening, Yashas. Let us continue. So the concept of first in, first out can be implemented with the help of front and back. If you remember, in the concept of a stack, we were doing first in, last out, and in that concept we were only using top as a variable, which was allowing us to implement the concept of first in, last out. But in queues, we are applying the concept of front and back, and to apply that we need two variables, front and back. We are applying the concept of first in and first out. Okay. Now in this case, in the beginning, the front and back, they both are set to -1. Why? Because it tells us that nothing is stored, nothing is getting stored, or nothing is actually stored in the beginning. Initially it will be nothing. Later on, I said I am going to enqueue. Enqueue is the term which we use for push. Basically, this is just push. Okay, I said let us push 10 as the first element. So to enqueue or push the first element, I would say that we would move this back once. we would move this back once, and then with the help of that I would just implement the push. Okay, I would just implement the push. So the element got entered right here. Okay, now I said that I wanted to do push, right? One more thing that I have told you, that is, for the first insertion the front will move 1 plus. You got it? Front will move 1 plus for this, the first iteration, for the first insertion basically, and then the insertion will happen. Later on, for more insertions, if I do one more enqueue, in that case back will again move on to the next element, and here the next element is pushed. So here let us say 20 is pushed, and one more element gets added up in the array. So pushing is very easy. I keep on adding the elements and the back moves one step ahead like this. I hope so that this is very much clear. Now the concept actually is strived when you are trying to pop an element. When we are trying to pop an element, what happens is that rather than deleting it from the back side of the array, we try to remove it from the front. And to control this only, we had the concept of front and back, where front will take care of the front of the array. That means whichever element got entered first, here 10 was the first element to enter. So a queue looks like this, right? So if 10 entered here first, 10 is the one to leave out first. You got my point? Mohammed Irfan, hello sir, hi sir, hello. Let's continue. So if the first element is entered first, that element is served first. Next is 20, so 20 will be served first. This concept is called as first in first out, or in this case this is the queues concept, where we are able to, what was entered first, 10 was entered first, and 10 is going to get be popped out first. And the concept of a front and back only allowed us to implement the concept of first in first out, or in this case in a short form I can say here QUEU. I hope so that this is very much clear, correct? Now, yep, I'm back. Actually, I have to manually push a button so that the camera doesn't go off. So in between, I'll be going like this and coming back again and again. Mohammed Irfan, sir, I have many queries related to DSA and I need your guidance. My paper is on 18th September. Yes, Mohammed. After the concept is over, I will have a small Q&A session. You can ask all your doubts here. You can just post your doubts here, and as soon as I finish up this, we can have a discussion about it. Okay, it will not take much time, and it is a very small concept that we will implement in next 15 to 20 minutes, and after that I will be able to solve your issues. Okay. Yes, I am live available. Yes, I can read your comments. I can read your comments and I can read your chats. So as soon as I finish this concept here, try to understand this concept also. This concept is very important, and this question is asked. So if you have any doubts, please ask me there, and as soon as I finish up this, I can answer your comments, answer to your questions. Okay, I can clear your queries related to DSA and your paper. Okay. Sir, there are a lot of questions related to graphs. Okay, we have not reached the graphs concept yet, but you post it. Let's see if we are able to solve it or not. Okay, we'll see. Well, okay, yeah, sure. So let us finish this up quickly and then I'll come back to you. Okay, all right. So now in this case we have this concept. We know this is the base of the concept. All right. Next up, what we are going to do is, using the same logic, we are going to build a queue with the help of object oriented programming, classes and objects, and we will be doing that in the style of linked list. So basically our basic base will be linked list, and that linked list will implement the concept of first in and first out. That means here we will be creating a class, and that class will be creating a class called as, let's say, queues, and that will have the attribute front and back, and using that front and back we will be able to implement the concept of first in and first out. Okay guys, so let us continue. So in this case I will be taking you towards the code, and we will start coding directly, because yesterday we have already understood the code for the stack. The same concept we have to apply, but here the elements which are going to get served first, they are going to enter first here. So let us implement the code. So I have written here hash include IO stream and using namespace std. Now what we are going to do is here, next up we are going to create our main function. Now main function I will be writing everything later on in the main function, but as of now I will be creating the class node here first. Why node class? Because it is a linked list and linked list will have node. So linked list class has to be implemented. We already know how a linked list class is implemented. Okay. So what we will do is, in the public section of the class, so I will say here public, in the public section of the class I will be writing int data. We already know the attributes of a node, so int data and node star next I will say. Okay. And the class ends with a semicolon, so don't forget that as well. Later on we will create the constructor, as you already know. If you don't know what is constructor, please go ahead and watch my C++ object oriented mastering C++ object oriented playlist. I will give the link in the description below. So it is 5.5 hour series. So if you watch that, you will be able to master C++ object oriented fully. So I will be creating a constructor. In the session 2 of that playlist, I have explained you about constructors, destructors, everything about it. So now I will be creating a constructor here. So I will say node star, so node and int data I will pass here, and I will say here this of data, basically here equals to data in this case, and this dot next equals to, I will be writing this of next actually. Okay, this of next is gonna be equals to null ptr. We already know this, we have discussed about it, why we are doing this, we already know about it very well. This is the constructor here, this is the attribute of the node class, and our node class is already ready for us to use. Now the next thing that we are gonna do here is gonna create our node, the queue class. Okay, so we are gonna create our class queues. So I will say class queue, class queue, and what will be the attribute of this node class? Just now we saw in the whiteboard that in terms of arrays it is front and back, so we can take that only, which will control the concept of first in and first out. So I will be creating that. So in this case I will say here in the abstracted way, so in the private section of the class, let us make sure that the abstraction level is also maintained here. So in the private section of the class I will be creating node star front, and I will be creating node star back. Okay, and here later on in the public section, this way if I make anything private, this way I will be able to maintain the abstraction level. Okay. Yeah, I know about Linguature, but it looks cool, no, I know, but the thing is that a lot of people who don't know about, or those people who are beginners, they won't understand what and how those symbols are coming from. That is why I don't use the Linguature. Okay, 1 minute, I will be back. I have to click one button on camera, otherwise my camera will get closed. Yeah, I am back. Okay, let's continue. Today I am alone creating this live, so I don't have any friend of mine that helps me in the live, so everything is on my own, so I have to control the camera itself. So I need to push the button again and again, I am saying, so apologies for that guys, but let's continue our class. Okay, so in this case we had the class queues, and in the private section of the class we say node star front and node star back. Okay, so these are the attributes of the class queue, and with the help of these we will be able to control the concept of first in, first out, and we will be able to create the queues. Okay. So, now the very first thing, and one more thing that I need to do here is going to be, create a public section of the class and create the constructor. Okay, that is very much important. So, I will be creating the constructor here, but first of all we need to write the public. So, I will say public here, and then I will say the constructor. So, constructor will be QUEUE, and here this will be a default constructor. Those people who do not know what is a default constructor, go ahead and watch my again C++ object oriented series as well. Okay. Now, inside this constructor, right now initially what I have told in the whiteboard is that initially they will be set to -1, or in this case we can take null. Okay. Because -1 was the index in the array. In linked list we are not doing that. So, in linked list we can initialize it to in the beginning we can initialize it to null. So, I can say here front equals to null and back equals to null. Okay, like this I can say. So, with the help of the public section and the constructor of the queue, we are able to do the queues. Okay. Next up, we are able to do the front and back initialization to null, which means it does not change in the beginning. It will initially it will be null. That means they are not pointing anywhere and no elements are there into our queue. Okay. Later on, let us write our first function, which is enqueue, or in this case push. We are going to use language that are used properly in terms of queues. So, I will say here void enqueue, I will say void enqueue, and here it is going to be a function which is going to take a value into val, and we are now trying to enqueue, or in this case push the element. So, you think about, if I want to push an element, what can I do in terms of queue? I can just push it into the front of the array, right? I have to, okay, listen, we will do something like this. What we are going to do is, if I wanted to push this first element, what would I do? First, I would have brought the back towards this side. That means back is equals to back of next. Back will move one forward, and then using that back we are able to implement the concept. So, in this case what I will do is, first of all, of course, because this is a linked list, I need to create a node, right. So, to create a node, what I will do is node star n is equals to new node, right, and here I will pass the val in the constructor call of this function. Okay. Now, here what I can do is, new node we have created, right. I can do one thing, that I can, because I have n, I can do one thing, that I can do front and back both is equals to n. I can initialize both front and back to n, which will allow me to initially set the values of front and back to n, which will have some particular value. Okay. So, I will say if, and this has to be, see the thing is that this is going to be a linked list, right, and linked list, what happens is that, okay, I will just draw it and I will show you. First, let me write the code. I will say here if the front is equals to null, that means if a front is null, which is right now, yes, it is null, I will say that, because you see we are trying to enqueue it towards the front. Why? Because the front is going to be the element which is going to get popped first. So, the element which is coming inside this queue will be served first. So, in this case, using that front, I will say if front is equals to null, that means towards front I need to push the element. I will say front equals to back equals to n, meaning in this case, you see what I did was, in this case In the very first pass, when I did the first, there will be a condition when both front and back are null. Yes, that was the first condition where it all started from. Now, when we try to do push, you see here, when we did it in using front and back in the array, what we did, when we wanted to push the first element 10, we moved front and back both together and we pointed it towards here. With the help of that, we inserted the value. So, same thing we are trying to do it here in the code. We said if the front is null, that means if the front of the array, because front of the array is the place where we are going to pop or serve the element first. So, in that case, if that is null, then what I will do is both front and back will be pointing towards n, which is the newly created node in this case. I hope so that this is very much clear. Okay. And later on, because now back has to move further for the next element to put on, what I will do is I will first come out of this, I will say return, this will be my first insertion and this will get over. If again it is called, front will not be null in the next pass, in the next, for first insertion. Front is null because in the constructor we have said first front is null. So, for the first insertion of the node, when the node is created and when the front is null, both front and back points towards the new one, the first element which is n here, and the element is pushed into the queue. Well, that was the first insertion. Then for the second insertion onwards, because front is not null now, we can move the back towards this back side of the array and we can use that back to push the element there. So, it is very simple that I can say here back of next is equals to n, and then back of next is equals to n. That means, okay, let me draw this out so that it is very much clear, because now we are in terms of, we are doing it in terms of linked list. So, imagine in the beginning you had front and back, okay, front and back both. Let me use smaller variables. I will use f capital and b capital. This is front and this is back, okay. This is front and this is back. They are like head, double head, okay. So, in a linked list normally you have an head which will point towards the first index. Right now both front and back are pointing towards null. That means there is no linked list, okay. Now, what we have done is we want to push the element. When we want to push the first element, let us say n is getting pushed, so we will create that node n. This is n node, okay. And let us say it can be something like, the data can be something like 10, okay. 10 is pushed, okay. So, now we will change that null to front and back both pointing towards n. This is what we are doing here in the code. If a front is equals to null, initially front and back they both were null, but we checked for front is equals to null. Yes, front was null in the first insertion. So, what we did is we pointed both front and back 1 1 and I pointed them to n. This is going to happen only for the first insertion. 1 minute, I need to press the button. Okay, I am back. So, this is going to happen for the first insertion, okay. Why? Because the front was pointing towards null. Understood my point? So, this first thing had to be done, that we had to do. Then later on for the next insertion, what will happen is that this back will move, back will access its own next batch, which means this next in this case, okay. Let me just write, say for example, this is null right now in the beginning, isn't it? This is null right now in the beginning for the first element, because this is the only element available. This is null itself, okay. Then what will happen is, what we have written is that back of next is equals to n. For the next iteration, see, I have returned from here. So, the first iteration is over, my first insertion is done, okay. In the next case, what we are doing is, let us say we have done the second push. As soon as the second push will come, again the new node will be created, okay. again the new node will be created. So this was the old n. Now this will be our new n. Understood? This is our new n. Let us say this time we are pushing 20. So now what will happen is, that I will say, is front is equals to null? No, this time front is not null. Front is pointing this old n. Got my point? Front is pointing towards old n. So this time this area, this part is not going to get executed. So where we will go, it will go here, because we will return for the first, this is only for the first insertion, as I told repeatedly. Now for the second insertion it will directly come here, and what is happening, back next will be pointing towards the new n. So I said back next is null, it will now point towards new n. Understood? Understood? This back was null. So we said now here that back of next is equals to n. So here back of next is this null, it will point towards n. So what will happen is, now this null will get deleted, this null will get deleted, and then this connection will be made. Back of next will point towards n. Understood? And then what we need to do later on, I need to point this back here. This is what it is, right? This is what we were doing in the array also, correct? So in this case we have to just write one more line here, that is back you point towards equals to n. This is your push operation or enqueue operation. Vandit Sharma, hello sir. Jatin, hi Vandit. Jatin Bhavane, sir, how are you? I am good. How to implement queues using a stack? That's a different concept. How to implement queues using a stack? See, stack is a very different concept. Queue is a very different concept. Okay, so you can implement a stack using another data structure like linked list, but here it is a totally different concept. And sir, can you explain it again? Yes, I can. Yes, I can. What we are doing here is, we are implementing the queues with the help of linked list. We are implementing the queue with the help of linked list. And to implement this, we need to know about linked list, how to create linked list. We need to know about queues, the basics of queues. In terms of queues, when we were doing queues, at that point of time, we have done in our very first second sessions, I have done the queue implementation using arrays, array implementation of queue basically, where I have used an array to implement the queue, to implement the concept of first in first out FIFO. Okay. So in this case, what we were doing is, we were in the terms of arrays, we were taking up the front and back as two variables, and because I wanted to implement first in first out, I created front and back as two different variables pointed in the starting as -1, and then when I wanted to push any element, like for example 10 was the first element, I said both front and back will move one forward. Front and back will move one forward, and using that I will push the element here 10. Okay. Now the next element will come, that is 20. This time for the next element, front will stay here. Front will stay here, keep an eye on this 10. Then back will move towards this side, to the back side of the array. So with the help of back, we will push 20 and 30 and keep on going on. Understood? So the first element which was entered is 10. We want to do first in first out. The first element which has entered has to go out first. In that scenario, 10 has to pop out first if I say pop, right? Or dequeue in this case, in this queues. So to take a track of the first element, we have created front. Front will remain until the first pop is done. Okay. back will keep on going on like this and front will stay up there. As soon as you say first pop, front will move here and this element gets deleted. Getting my point? So now if you want to implement this into, yes, why we are not incrementing front? Yes, we are incrementing front. We have to increment this front. We will have to increment this front. Because front is the way of popping out the first element. You are right, Jatin. We need to increment front. Because front is the variable which will actually delete the first element. That is the one who is keeping an eye on the very first element which got entered in the queue. Yeah, front will be used for dequeuing. Correct. Okay. I hope so your doubt is very much clear, Jatin. Moving on. Moving on. Yes. So in this case, now when we started implementing, you see, understood the concept of arrays, implementation of queues. Now when we tried to do it in linked list, again you see here, again I'll explain you, don't worry. Again I'll explain you, don't worry, let us understand it from the beginning. We don't have anything right now, but we know this, that a queue will contain two attributes, front and back, correct? Front and back it will contain. So I said F for front and B for back. This in the initial stages, when nothing is pushed, they both will be pointing towards some null. Null means nothing is there. There is no element being pushed here. Okay. Now to implement our first element, you see here I have created the queue, class queue, and in the private section of the class we have taken node front and node back as two pointers which will point towards initially null. With the help of a default constructor, I have initialized both of them to null and null. Okay. So now with the help of default constructor we have done it. If you don't know what is default constructor, go ahead and watch my C++ object oriented, again I am saying playlist. Okay. You will master it. Session number 2 in there. Okay. Then I have written this enqueue or push. Okay. So how would you push? That is my question. To do your first push, start by creating the node. Start by creating the node. So node star n is equals to new node. We already have understood this, how we will create the node. Okay. Start by creating the node. Okay, I said I have created the node. I said I have created the node. I'm not right now, I'm not pointing any of this front and back, but I am saying that I started creating the node. This is my first node. Imagine. And the value is, let's say 10. And the value is, let's say 10. Okay. Now what I have written in the code? If a front is equals to null, is a front equals to null? Yes, front is equals to null. It is not pointing anywhere. Because in the concept of arrays also, you see, front and back initially was pointing towards -1, but there is no condition of saying -1 in the linked list concept. We can say null. So in this case of linked list, both front and back are null. Initially they are null. And while, remember that while dequeuing we will be using front. Wait a minute guys, I need to click on to this. Today I am, again I am saying, today I am operating the camera alone, so that's why in between it can go. So give me 1-2 seconds, I'll push the camera button and it will come back. Okay. Let us continue. Okay. So now front and back are both pointing towards null in the beginning. Okay. And remember this, that front is the variable which allows us to dequeue the entry first. So I checked for, in the code, I checked for front is equals to null. Understood this? And I said when front is equals to null, of course in the first insertion, front and back they both were null. So front is equals to null here. So when front is equals to null, what you do is, you say front equals to back equals to n. Means both front and back are going to point towards this newly created n. This is the n, right? This is the n, right? Correct. So I said front and back will point towards n, both of them. Got it? Now return, come out. Our first insertion is done, over. What is the next value here? Null. Okay. N of next is equals to null right now. Okay. Now, we said return means come out. Our first insertion is over. First push is done. Enqueue is done. Our first enqueue is done. Okay. Next up, I said for the next push, what we will do? For the next push, we will do this, that it will again check, it will create another new node. It creates another new node. So, there you go, it will create this new node. It will create this new node. Okay. And let us say 20 is the value. Okay. Now, is the front is equals to null? Is this front is equals to null? No. This time front is pointing towards n now. So, what will happen is that this part will not get executed anymore. Rather, it is going to create a new node here and then it is going to directly jump from here to here. Understood? It will jump from here to here directly, from line number 28 to line number 32 it will directly jump. Hope so it is very much clear. And what will happen? Back of next is equals to n. What is back? Back is n. Back of next, which is null, will be equals to this new n. This was the new n, this was the old n, right? Old n was that from the previous insertion. New n is this, which is new node. So, back of next, which was null, is equals to n. So, this is connected with this. This connection is made. So, in this, we will remove this null and we will put this n. So, connection is made. Okay. This is what happens. And then the back should point towards n, no. So, what I will do is, I will move this back right here. This is how the push will happen. Got it? Now, this part is null. Okay. Let us say you are doing one more push, and as soon as you did one more push, what happened? This is now old n. You will start by creating a new node. This is the new n now. Okay. Let us say this is 30. This is null by default. What you will do now? Again, front is not equals to null. That means front is not equals to null. That means it will once this node is created new n, it will directly jump here again. It will directly jump from there to here, and back of next is equals to null will happen. Back of next, which was null, is equals to n will happen, and this connection will be made. So, this is gonna get deleted, and here I will put n, which is the new n, and there you go, the insertion is done like this. So, this is how the enqueue works. I hope so that this is very much clear to all of you. Okay. So, our enqueue function is this. Wait a minute, something happened to my smart board. It's not working, it's suddenly stopped working. Nothing. Apologies guys, suddenly stopped working. Let me check the camera. Okay, it's not working. Is it working? It's not working. Okay, yeah, it started working back. It's back online. Okay. Okay, so this is the enqueue function. Now dequeue, the next function. Okay, let us do the dequeue. So I said void dequeue, dequeue. Okay. How you will do dequeue? For dequeuing, you need to check for underflow condition. And if you want to check for underflow condition, what do you check? You check if front is equals to null. Of course, if this front is null, that means this node is not there. That means linked list is not present, because every node is connected like this. Correct? So in this case, what happens is that if this only is null, that means it is underflown. So you cannot delete any element. So, I will quickly write the code for it. If front is equals to null, C out, I will put QUE under flown. That means we cannot delete any element in this case, because nothing is there to pop, actually. Okay. And then just say return directly, come out of the this thing. Hope so that this is very much clear. Okay. Now, if I want to delete, what will get delete here? The front will get delete here. That means you need to do delete at end. So, what you do? You can store this front into a variable, temporary variable, to delete. Okay. What I will do is, I will store this front into to delete variable, to delete, or maybe this is temp, whatever you would like to call. I said node star to delete. To delete variable is a pointer which is pointing towards the element which is going to get deleted very soon. I will store this and I will say front, you do one thing, that you move on here now. Front, you move on here now, and I will say delete to delete. I will say delete dynamic memory allocation, delete to delete. Delete this. This got deleted and the thing was clear. I hope so that this is very much clear. Done. Okay. So, we will code for this. Let us code for this as well. So, I will say here node star to delete, node star to delete, I will say equals to front, and then front you move on front of next. Okay. Understood? And I do not want my back also to go out of bounds. So, in that case, what will happen is, I will check for one more condition. If front is now equals to null, then in that case make sure that the back is also equals to null. Okay. This condition. And then last, I will say delete the to delete actually. This is going to be the dequeue function. Here we are playing with the front and moving the front towards that back side of the array. This is the code for this. So, guys, the concept of first in first out is implemented. I hope so that this is very much clear to all of you. But let us continue to create a queue and let us write the remaining two more functions of queue. And what is those two functions? What are those two functions? Peak and is empty, because we had created this in our array implementation. So, let us try to implement them here in the linked list style. How would you do this? Let us see. So, I will create two more functions here. Int peak, which is going, why int peak? Because it is going to return the frontmost value which is going to get deleted, right. So, in this case what happens? I will have to check if there is front element or not. So, I will have to check this. Same thing, if front is equals to null, then in this case queue is underflown, and in this case return -1. Why? Because we are returning a negative, we are returning the int type of value. I hope so that this is very much clear. Okay. After this, I will return, if this is not true, then what do you have to return? Return the front of data. Very simple. This is the peak function, where you are going to just peek and understand what element is going to get deleted. And to peek, you know front is going to get deleted first. While dequeuing, we have done that. So, we will peek on the front. Got it, guys? right. Next up, we are going to create our last function, and that is going to be bool is empty. Bool is empty, and I will say here, what do I say here? Return front equals to null. I have explained this one single line function yesterday also, where I have explained you that you return this value, this expression. If this expression is really true, because your function is anyways returning a boolean value, if this expression is really true, it will return true, otherwise it will return false. I hope so that this is very much clear to all of you guys. And there you go, we have implemented the linked list implementation of queues. Congratulations guys, today you have studied about queues implemented using list. Acha, one more thing, we did not had anything to see if it really works or not. We need to execute the program also. So one function which is left, that is going to be the display function. You know how to write display function, right? Let's write the display function very much quickly. So I'm going to say here void display, and here I'm going to say, here what I'm going to say is, I'm going to create a node star temporary, which will start from the front, and while the temp doesn't becomes equals to null, keep on doing print the temp of data, and I'll print some arrow here like this, and temp you move forward. So temp is equals to temp of next. Okay, and later on at the end, to make it look nicer, I'll say null. Okay, and L. So this is your display function. So this is absolutely very much clear to all of you. Now let us go into the main function. So this is the final version of our function of our program, where we started by creating, just recap it quickly. We created the class node, and here we will remove this breakpoint. Okay. So we created this node class where we have data, next, and the constructor through which we were doing it. It is in the public, right? Everything is correct. Now in the queue class, the private, in the private we declared the front and back, and in the public we initialize them to null and null. In the enqueue, we are creating the new node, and we are saying that if the front is equals to null, both front and back move to the new node, and this is the first insertion. Then the back will go to the next, and then it will point towards the newly created node, and back will point towards end. This is your push. And dequeue is the place where you will just move the front towards this back side, and you make back as also null if front is null, because you don't want that condition to overrun the back. Then delete the to delete. You have stored the first node, which is front node, into to delete. Then peek is simple, you just have to return the front of data, because front is somewhat which is going to get deleted first. Bool is empty, will return if the front is value is equals to null or not, it will return it in true or false. Then here this is our display function. Everyone knows about the display function. And now in the main function, let's write the code and check for if it really executes or not. So let's start by implementing the queue object. So I'll say queue like this, and I will say here, let us do some cout. Wait guys, one more time I need to press the button. Probably this is going to be the last time I have to press the button. Okay, yeah, I'm back. I hope so I'm audible as well. Am I audible? Hello, yes, I am audible. Okay. So here I've said that queue as an object, and I said cout, I will say here enqueue operation, enqueue operation I will do, and here I said end L. I am going to say here q dot enqueue function. I called this enqueue function, and I passed, let's say 10. Okay, I enqueued 10. So like that I enqueued this. Now what I'll do is I'll copy the same thing and I'll enqueue more and more and more. So I'll say here it is 20, 30, 40, 50. I enqueued 5 items here. Okay. Sir, please teach us implementing stack using queues and vice versa also today. Stack using queues, we can take that concept up tomorrow, because already time is over for the live session. Yeah, we can cover it in tomorrow's class. Don't worry, I am coming every day at 7 o'clock. Okay, 7 o'clock to 8 o'clock. Just if you want a specific kind of a topic, please do let me know before, only in the comment section or in the social media, and I will be covering that concept that day. Okay, I can do that. I can come live for you guys and I can do that. That concept will also come later on. Okay, what you are saying is that concept is going to come later on, because now we have understood queues and stacks. We can do that concept now. So maybe I can cover that in tomorrow's class. Okay. Okay, and after that later on you can say queue dot display. Okay, and then we will, the enqueue function is done. So let us run it and check if it works or not. So far it is working. Yes, it is working fine. So you can see that the first element got entered as 10, 20, 30, 40, 50, 60, right, like this. This is going to be implementation of queues using linked list, and let us do some dequeue operation. Okay, so I'll just copy this out. I'll copy this out and I'll say here dequeue. Yes, Mohammed, and I am so much confused in graphs, shortest path and tricky things. Okay, so it is on 18th September, right? Wait, I'll come back to you, Mohammed. Let me just finish it in just 2 minutes. I'll finish this off. Okay. Yeah. So now after this, I will say here queue dot dequeue, like this. Don't worry, Mohammed, I am there. I will be helping you regarding that. I'll clear your doubts. Don't worry. Okay, I'll teach you. I'll teach that concept explicitly. I will come live for graphs separately. Okay, because this series is actually being continued in a proper sequence manner, and to reach graphs it will take time. But if you want, I can create dedicatedly. I can take up your topics especially, and I can create a video on that, so that it is very much clear to you. That is what I can do. Understood? I can create a dedicated video on, you want shortest path, right? Dijkstra's algorithm, minimum spanning trees, and all those things. I will create a dedicated video on that, explaining each and everything. Okay, BFS, DFS, everything for graphs. Okay, but to reach that concept, it takes a little bit of time, because we need to understand about the trees concept also. Okay, but I'll note it down. I'll create whatever is there. You please tell me in the topics. Stay connected with us. I'll be there always to help. And if you tell me the concepts, this way I'll also get the content to create, and you will also get your videos with my explanation. For your doubt clearation, I can come live for a specific doubt session. Okay, let me just finish this off quickly. Okay, I'll say here queue dot dequeue, and when I say dequeue, the first element, which is 10, which will get dequeued, and later on I'll just display. So queue dot display. Okay, we'll run it and see if it works or not, and there you go, it works absolutely fine. Absolutely fine. So guys, this is how you are going to implement the queues using linked list concept like this. I hope so. This is really very clear. I hope so that this is really clear. Okay. So here we go. This is the program. I will give the link of the whiteboard and the code in the description below. I've still not have posted all the codes. It is another task which I need to do, of course, because I was creating the live sessions. I have forgotten to post all the codes. manually I will post all of the codes. I'll give the file .cpp file link of Google Drive link of all these programs into the description below. It may take some time. In 1 or 2 days I will be keeping that of all the programs in the description below, so you can get it. Okay, no worries about it. And there you go, this is the code which we are talking about. Today's concept is over. Now if you have any doubts, let us start our Q&A session, where I will be solving your doubts. I will be answering your questions of whatever you want to ask from me. You can now ask. Let us solve Mohammad Irfan's doubt first. So Mohammad Irfan, as you said that here in the very beginning you said your papers are on 18th September and today is 3rd September, 18th September. We have almost 2 weeks, 2.5, almost roughly 2 weeks. 2 weeks we can take. Okay. So if you want to get ready, I'll get the contents, you tell me the concepts, what all need to be cleared. I can come, either I can come live specifically for that, taking the concept specifically live, I can come for that, or I can create videos on your issue. Okay, Mohammed. So I can do that. I'll be available to solve any type of doubt you have related to your technical stuff in DSA. Let me just press the button of the camera so that it doesn't go off when battery is also about to get over. But I'm back here. Okay, I can read the comments, but you have to tell me. Sir, is Prim's algorithm is possible to, sir, in Prim's algorithm, is it possible to visit 2 nodes, a node 2 times? No. In Prim's algorithm, what is Prim's algorithm? Prim's algorithm is the algorithm which allows us to find the minimum spanning tree, basically MST. Understood? So MST is going to, MST is what? MST is this. Now the rest of the code is for doubts. What is MST? MST stands for minimum spanning trees. Okay. It doesn't matter to get to the node multiple times. Basically, let us say I have created, wait, I'll take one example. I have an example, just wait, I have got a very nice example actually in my notes that I'll be showing you. Wait. A very nice example I want to show you. Okay. So now listen. If we are talking about, these are my notes, I'll be using these. I have some of my examples that I'll be taking up to explain you about what exactly is minimum spanning tree. Okay. Take one example. Okay. We are going to take one example. Let's say we have this graph. We have this graph 3, this is 4. Okay. okay, like this. Okay, so we have a graph. In our past paper, there is a question related to spanning tree using prims, and I have solved that tree, but according to me, it is not fulfilling prims algorithm because the nodes are missing when I was traversing. Okay, listen to this, Mohammed. Nodes are not going to get deleted, or nodes should not be missing. That means something was wrong into your algorithm. What you need to do is, what is actually MST? For example, take this example where you have this tree, this graph, this is one graph, okay? This is one graph. Now, in this graph, if I want to create its MST or minimum spanning tree, the correct way of creating minimum spanning tree is that the nodes, number of nodes will remain the same. Okay. How many nodes are there? 1, 2, 3, 4, 5. We have 5 nodes. We have 5 nodes. Okay. But the edges, how many edges are there? 1, 2, 3, 4, 5, 6. 6 edges are there. So 6 edges will be 1 less than the nodes, number of nodes. So in this case, we will be taking up, so right now in this, how many nodes are there? 5 nodes and 6 edges. Okay. So its MST would be 5 nodes but 4 edges. You got my point? 5 nodes but 4 edges. Edges count should be 1 less than the number of nodes. Then it is called as MST. Okay. This is your MST. Now, what can be the minimum spanning tree of this? Let's take an example. I'm going to recreate this again. Okay. So, I had this 0, 1, 2, then I have here 3, then this is gonna be 4, and the edge weights are given as 6, 8, 2, 5, 3, 7. Okay. Say for example, we have this graph. Okay. We have this graph and I want to find its minimum spanning tree. Now, according to the rule, right now we have 5 nodes and 4 edges, sorry, not 4 edges, 6 edges, 5 nodes and 6 edges. To find its minimum spanning tree would be 5 nodes but 4 edges. 5 nodes but 4 edges. 5 nodes but 4 edges. Okay. What can be the possible spanning trees that you can create? Okay. The first spanning tree that you can create is gonna be this. This is our first spanning tree. Okay. Where this is 2, this is 3, this is 5, this is 5, this is 8, correct? Okay. So, what are the total number of weight here? 2 plus 3 plus 8 plus 5, it is gonna be 18. Okay, it is gonna be 18 here. The weights are, total number of weights are 18, correct? So, this is 18. What else can be created out of it? We can create more spanning trees out of it. The next spanning tree that I can create is this. correct? This is our second spanning tree, where this is 6, this is 7, this is 2, this is 3, correct? You see, number of edges are same, number of nodes are same, but the number of edges are one less, okay, one less. In terms of this, you see 1, 2, 3, 4 edges and 5 nodes. Here in this case 4 edges and 5 nodes. We are trying to, guys wait, battery is gone guys, let me change the battery here quickly. Changing the battery guys, coming up quickly. There we go, we are back. Is it visible guys again? I hope so. Yeah, I am back. Yeah, actually the battery got over, so I need to change the battery for the camera, so I just changed it. As I told you, I am alone all here in my office, so I am only doing it, so bear with it, apologies for that. Okay, so as I told you, minimum spanning tree is gonna be, for minimum spanning tree, right now these are all different spanning trees, but none of them are minimum spanning tree. We will have to find our minimum spanning tree. Okay, the formula of finding up the minimum spanning tree is that in the out of the original nodes will be the same, but the number of edges will be one lesser than the node. So if you see this is our original graph. Number one spanning tree that can be created out of that is keep this all the nodes, but reduce the number of edges. Okay, this is one possible spanning tree. The next spanning tree could be this, out of that, where these are number of 4 nodes are there, nodes are all, but 4 edges are there. Okay, third that we can create is gonna be somewhat like this. Third is gonna be our W shape. Create like this. Okay, this can be the spanning tree. Okay, this can be the spanning tree. Okay, where the weights can be, this is gonna be 6, this is gonna be 8, this is gonna be 5, this is gonna be 7. Okay, so what is the total weight in this one? Total weight here is equals to 18. 6, 2, 3, 7. Here 6, 8, 5, 7. What is the total weight coming up? 26. Okay, total weight is 26. How many spanning trees we created? Number 1 spanning tree is that. Number 2 spanning tree is this. Number 3 spanning tree is this. What is the 4th spanning tree that we can create out of this graph? Check. We can create this. Okay, we can create this, where the number of edges are 6, 2, 5, 3. 6 plus 2 plus 5 plus 3. What is the weight? 16. What is the weight? 16. Now, compare all the weights. Of out of all the spanning trees. See, what is the weight of this spanning tree? 18. What is the weight of the spanning tree? 18. What is the weight of this spanning tree? 26. What is the weight of this spanning tree? 16. Whichever spanning tree's weight comes lowest, following the rule of MST that the number of nodes will remain the same, but the edges will be one lesser than the node. In that case, this becomes our MST. This is our MST. And Prim's algorithm allows us to calculate or get the MST. Alright guys, I hope so that this is very much clear. Mohammad Irfan. Okay. I hope so that this doubt is clear. Well, any other doubts? Okay, got it, sir. Okay, so this is your MST. Now, PRIMS is an algorithm which allows you to find this MST. Yeah, just remember always that MST is all the nodes one lesser edge than the number of nodes. And you have to create the spanning trees, possible spanning trees, jot it down in a rough paper, create the spanning tree. Sir, can we get the copy of your notes? I have created the PDF. I will send you the PDF. I will later on attach in one or two. I don't have the proper copy. This is just a rough notebook where I have kept all my notes. If it is possible, because it's not clear, what I will do is I'll take a photo and I'll create a PDF. Give me 1 or 2 days time. 1 or 2 days time, I will properly create notes and I'll post it as the link of all these videos. I'll post the link of the DSA notes in the description. Okay. I have to organize all my notes because I have notes kept somewhere here, somewhere there. So it is not an organized collection right now. Of course, I am teaching DSA, teaching you how to organize the data, but my data is not only organized here in terms of notes. So what I will be doing is, let me just organize my notes here and then I will come back to you with organized notes. Give me 1 or 2 days where I will give you a link. And don't worry, Mohammed, you have 18th of September, we have 2 weeks of time. Together we will work on and we will see how you will be able to, how not you will be able to learn. I will make you learn, and for that every day just keep on attending my live sessions and I will be going live, or maybe I will be creating a video especially for you for your doubts. So keep on asking me doubts. Sir, can I contact you personally? You can contact me on our company's number that is given into our description, not in description, but in the about section of our YouTube. I'll put the number in the description also, so you can get in touch with our company. See, this is my startup and Coders Arcade is my startup, and we are starting to provide placements also. We are getting in touch with companies and we are trying to get tied up with so many other companies which can give placements also. So right now I am trying my best to get deals with companies who can provide placements so that I can also give the placements opportunity to you guys. Okay. I have my own training institute and I teach there. In our offline batch, I do teach DSA, machine learning, data science, C, C++, Java, Python. I teach in offline batches. If you want to join my offline batch, or if you can't, then if you want to join my online batch also, we can do that. You want a crash course, we can do that also. Okay. Dedicatedly 2, 2, 3, 3, 4, 4 hours a day, we can do that. This is our number coming up into our description, into our chats. So you can see this is our company's number. If you want, you can join our personal batches where I will be the trainer and you will be able to directly be in touch with me. Sir, is there any +91 in the start? Yes, this is because okay, yeah. Okay, so for that online batches, yeah, this is an Indian number, so you can contact me here on this number. Yes, +91 is going to be there. Yes, +91 is going to be there. It is there in the chat. Well, don't worry Mohammed Irfan, we will be helping you in terms of DSA. Okay, don't worry about that. Okay, I'll be there, my company is there, we can do a quick crash course if you want, and we can do that. Okay, or maybe in terms of live I can come, in terms of live I can come and clear your doubts. Okay, this is just the beginning. This is just the beginning. We'll keep on growing, and we are trying best that our students also keeps on growing. For that, we are getting in touch with companies, IT companies in India that will provide placements. So soon we are going to start placing our students also. So if you are interested, you can contact us onto this number, and we can join a course. For special doubt sessions, no worries, doubt clearance I can do in live session. I can come dedicatedly live for that. Okay, wait a minute, I need to again press a button, sorry for that. I'm back. Okay guys, I hope so that this is enough for today. Any other doubts that I can clear? I hope so that you have understood the MST concept. Yes, it is paid, but first contact us, where I will be telling you how it works. Okay, don't worry about that. Our YouTube is fully free, it is not paid. So on YouTube I can come live for you, and you can get your doubts clear. So no worries, no worries. But if you want a dedicated course, then dedicated course would be paid. MST is clear, right? Apart from MST, any other concept, please do join me every day at same 7 o'clock. I will be there available to clear your doubts and teach you DSA. Okay, every day I will be coming live for DSA. Usually for this week it is 7 p.m. in the evening, but other days maybe 6 p.m. 6 or 7 p.m. I will be updating that in our videos. And don't worry if you have missed any video, because we are recording these sessions, and we are posting them onto our YouTube playlist. Yep. Yes, thank you Mohammed Irfan. I hope so that my job is done for today. We will conclude this live session, and I will see you guys again tomorrow evening. Okay, tomorrow evening, and yep, that's it for today's session, guys. Thank you so much for interacting with us. Thank you so much. Is it possible to cover trees and grass ASAP? Yes, it is possible. We can plan onto it and we can cover. Well, next concept is trees only, by the way. Priority queues we had to do, but we can try understanding trees. I can take a dedicated class, or I'll do one thing. I'll come dedicatedly live for trees and graphs concept. Separately I can do that. Okay. I'll cover it, don't worry. Before your exams I will cover it, don't worry. Because these days, actually this week I am very much busy, because I am going to colleges also, and I am coming live also. So I don't usually get much time to create extra videos. But after this week is over, not even this week, actually till Thursday, 2 days more. After 2 days I will be doing all these things for YouTube. So I will be creating videos and I will be coming live. I can come two times live in a day. So no worries. Alright. Well, let us conclude this session, guys. I thank you so much for being with me live till the end of this session. Any other doubts, please contact me again every day in the evening 7 o'clock. I am coming for this week. Apart from that, if you have any problems or doubt, please let us know in the comment section below, and all the resources and everything will be sticked onto the description. I will be sending all the codes also and all the files into a separate Google Drive file. Very soon I will be uploading that, and I can definitely do a lot of concepts. We will keep on learning, guys, so don't worry about it. Time for me to leave, and I will see you again tomorrow evening at 7 o'clock. Okay, guys? Thank you so much. Let us conclude this. Okay, guys? Thank you so much. Vishal M, Mohammed, Irfan, and so many people are there. Jatin, Vandit, Sharma, Yashas Gowda, thank you so much. And I will see you tomorrow. Bye bye, take care, stay safe, stay healthy, and happy learning from Coders Arcade. This is Ashank David signing off.